You ever wonder what the big bang moment for modern AI really was? Well, a lot of people would point right here to a 2017 paper from a team at Google called Attention is All You Need. Now, it might not look like much, but this paper, it introduced an idea so powerful it literally became the blueprint for the AI we all use today, from ChatGPT to Gemini. And to really get why this paper was such a game changer, we first have to think about something super basic: how we and computers actually understand a simple sentence.
So let me ask you a simple question. How do you read a sentence? Do you read it one word at a time, forgetting the beginning by the time you hit the end? Yeah, probably not. Your brain just kinda effortlessly connects everything, right? It links the subject at the start with what's happening at the end, and it gets the relationships between all the words at once. For the longest time, AI just couldn't do that. You see, before this paper, the big AI models were stuck in the old way, processing language one painful word after another, and that was a huge limitation. The new idea, the one in this paper, was to let the model see the whole picture, all at once, just like we do. And believe me, that changed everything.
To really get a handle on this breakthrough, we first need to understand the wall that researchers had basically hit. It all comes down to what the paper calls the sequential problem.
Okay, so back then, the big players were these models called recurrent neural networks, or RNNs, and the name kind of says it all. They were recurrent. They'd take in one word, do some math, and then feed that result right back into the equation for the very next word in line.
And yeah, this is pretty much what it looked like. Just a step-by-step chain. You literally couldn't process word 3 until you were done with word 2, and you couldn't touch word 2 until you were done with word 1. You can already see the bottleneck forming, right?
This whole one after the other thing, it created two huge problems. First, it was just agonizingly slow, because everything had to be in order. You couldn't really use all that powerful parallel computing we have to speed things up. Second, and maybe even more important, these models were, well, they were forgetful. By the time an RNN got to the end of a long paragraph, it often had no idea what happened at the beginning. Learning those connections between distant words was, as the paper put it, a key challenge.
But what's really cool is how the paper actually puts numbers to this problem. This is straight from Table 1 in the paper. For an old recurrent network, the number of steps it takes is O(n). Now that's just a fancy way of saying the time it takes grows with the length of the sentence, n. More words, more time. Simple as that. But look at their new idea, self-attention. It's O(1). That means it's a constant time. It takes just one single computational step to see all the words, whether the sentence is 10 words long or 10,000. I mean, this wasn't just an improvement, it was a complete game changer in efficiency.
So, how in the world did they pull off that incredible leap? Well, they did it by basically throwing out the old rulebook and focusing on one single, incredibly powerful idea. And that brings us to the absolute heart of this paper.
The magic ingredient here, it's called self-attention. Think about it like this. Instead of listening to a recording of a long meeting from start to finish, what if you just got the entire transcript at once? You could instantly see how a comment made in the first minute connects to a decision made in the last hour. That is exactly what self-attention lets the model do. Weigh every single word against every other word in the sentence, all at the same time.
And you know, the authors weren't shy about how big of a deal this was. This quote from the paper's abstract is basically their mission statement. They're not just tweaking the old models, they're proposing a totally new architecture, the transformer, and throwing out the old sequential stuff for good.
All right, so let's dive into this new architecture that would go on to change the world and see exactly how it's built on that core idea of attention.
So the transformer, it's built on a few really key ideas. First, like the title says, attention is all you need. No more recurrence. Second, it uses a classic setup called an encoder-decoder. You can think of it like a human translator. The encoder reads and understands the sentence in one language, and then the decoder writes the new sentence in another. And third, it doesn't just use one attention mechanism. It uses a bunch of them in parallel, a trick they call multi-head attention. And this is such a great way to think about why this is so powerful. Instead of asking one person to read a sentence, imagine you ask 8 different specialists to look at it. You know, one might focus on the grammar, another on who's doing what to whom, a third on the overall topic. By combining all those different perspectives, you get a way richer, more nuanced understanding. That's multi-head attention in a nutshell.
Look, a cool new architecture is one thing, but what about the results, right? Were they any good? Well, for the transformer, the results weren't just good, they were completely revolutionary.
Okay, So just look at this data from the paper. On a standard English to German translation test, the Transformer got a blue score, that's basically a grade for translation quality, of 28.4. Now, that number might not sound huge, but it was an improvement of over 2 full points on the previous best model. In this field, that's not just a step forward, that is a giant leap.
And here's the kicker. It hit that record-breaking score after training for just 3.5 days on 8 GPUs. The paper even notes this was a small fraction of the training costs of the other top models. So get this, it wasn't just better, it was way faster and cheaper to train.
And it wasn't a one-off thing either. On the English to French translation task, the Transformer did it again, setting a new state-of-the-art score of 41.8. The proof was in the pudding. This new architecture was just better. All right, so it was a translation champion. Big deal, right? So why are we still talking about a paper from 2017 today? Well, because its impact went way, way beyond just machine translation. It laid a whole new foundation.
I have a feeling you've recognized these 3 letters. They've pretty much become synonymous with the AI revolution we're all living through right now.
So what does GPT actually stand for? Generative, pre-trained, transformer. There it is, the T that changed the world. The architecture described in this very paper is the engine humming inside the most advanced language models we have today.
You see, this wasn't just another small step. The Transformer was a true paradigm shift. It gave us the blueprint, the scalable, parallel, and super powerful foundation that was absolutely necessary to build the massive language models that are redefining how we think about technology, creativity, and even work itself.
The jump from going word by word to seeing everything at once unlocked the entire AI revolution we see today. So it really makes you wonder, right? What's the fundamental problem we're stuck on now? And what's the next simple, elegant idea that's going to come along and change everything all over again?